Welcome back. In the last session, we had seen the voltage gain, and we got to know that the voltage gain is function of H parameters, and H parameters in turn depend on temperature, replacement, and age. Okay, and because of all these three, your H parameters are changing, therefore your voltage gain is changing, therefore it is not stable. If you want gain stability, then we have to improve the gain stability, not gain, improve the gain stability. Okay, tell me, what will you do to improve the gain stability? Therefore, I am going to explain the solution in this session. I am going to explain the solution to improve the stability, but not necessarily you will use that circuit or you will use that technique, because if you want gain stability, then only you will go for it. If you don't want gain stability, that is fine. Example, let me tell you. Take op amp, right? If you take IC 741 op amp, you know what is the gain? 2 lakhs. I am speaking absolute terms, 2 into 10 to the power of 5, 2 lakhs or 106 dB. Now, when I say 2 lakhs, right, which you are treating as infinity. Now, strictly speaking, the 2 lakhs gain is not constant, that is varying. That is varying with respect to temperature. If that is what is varying with respect to temperature, let us say 2 lakh gain is becoming 2,20,000. Doesn't matter. Why? Gain itself is infinity. Infinity plus something, infinity. The 2 lakh is becoming 1,80,000 or 1,70,000. Doesn't matter. Because infinity minus something, infinity. Right? But remember, the 2 lakh should not be 100 and all. Open loop gain should not be like 2 lakh is becoming 100 or 200. No, that is not acceptable. Right? Therefore, remember the gain variation, right? That is what is acceptable in the case of op amp, because the gain itself is very high, plus or minus something is not impacting your overall system's response, then the single entity, the sub entity variation is not impacting the total system's response, doesn't matter. Therefore, ultimately the requirement or the spec is very important. Therefore, sometimes I need stable gain, right, where you deal with like 10. For example, I want gain of 10, but that should be stable. If 10 is becoming 12, 10 is becoming 8, that is significant, which may change the system's response, overall system's response. In that case, I want gain stability. I hope this is clear. Whenever you want gain stability, go for it. If you don't want gain stability, go for more gain. Right? Let's see. Let's see the solution for what? Solution to improve gain stability. Now, let me ask you a question. If you take a common emitter amplifier, therefore, if you take common emitter amplifier, this is nothing but your common emitter amplifier, which we had seen, and that is what is your default amplifier. This is what is your default amplifier. Basically, if I give only AC circuit part, right? Now, I am not representing VS and RS. Ultimately, this is what is the signal where your amplifier is amplifying, and this is what is your V0 and RC. You can make it ground for AC analysis, and let us keep VCC. That is fine. As far as you know what is it doing, that is fine. Now, this is what is your common emitter amplifier. For this, let us assume that if the load is less than or equal to 4K, then I can go for simplified model. Then what is the voltage gain we got? AV is equal to minus HFE into what is RL? RL is nothing but RC here, therefore divided by HIE, and this is not stable. This is not stable. Therefore, your voltage gain is not stable. It has some variation because of temperature, because of time, because of replacement, because of H parameters, fundamentally because of H parameters, because H parameters in turn depend on all those things. Now how to improve it? How to improve? From circuit perspective, if you think how to improve the gain. Improve in the sense, I want to improve the stability. If I want to improve the stability, can I say one thing? If my voltage gain is independent of H parameters, problem is over. Can I say that? If my voltage gain is independent of H parameters, then problem is over, because Your H parameters are depending on all those variations what I told before. That's why gain is not stable. If you can make voltage gain independent of H parameters, then you will get stable gain. That is from qualitative part. But let me ask you a generic question. How to improve that and how to make the circuit independent of H parameters? That is very difficult question. How to make the circuit independent of H parameters? Take out transistors. Transistors are only having H parameters. Take out transistors. If you take out transistors, gone, no amplification. Then how to make voltage gain independent of H parameters? The solution, whatever generic solution I'm saying, make the circuit which is independent of H parameters. Easy, but how to implement practically? That is very difficult, right? Now, let me ask the same question in a different way. Definitely you will answer. Definitely you will get it. What is the technique to improve system stability? If I speak from control systems, if you want to improve open loop system, G of S, if you want to improve the system's stability, what will you do? Yes, I know, you will tell the answer. Therefore, that is nothing but negative feedback. Therefore, wherever you want to improve the stability, remember, incorporate negative feedback. If you incorporate negative feedback, the system's stability will increase, obviously. But remember, negative feedback, not positive feedback. If you apply positive feedback, the system's stability will go back. Okay? Therefore, let us apply negative feedback for the circuit. That will take care automatically, and we will get a condition also to get the voltage gain independent of H parameters, which will satisfy saying that it will get voltage gain independent of H parameters, or your voltage gain will be stable. What is the technique to improve the gain stability? The technique to improve the gain stability is nothing but negative feedback. Okay? Now let's incorporate negative feedback. Then let's calculate all AC parameters. Then I'll come back to the voltage gain, and then let's check whether after incorporating negative feedback, whether the voltage gain is independent of H parameters, or I can say is that stable, right? Let's see. Now what I want to say, the negative feedback, right? Therefore incorporating negative feedback, maybe you can try it. Then I'll draw that circuit. Then we will see the AC parameters. This is known to you, but just I am writing just to have the comparison. Okay. Now I am going to give the circuit name, but let me give the circuit, then you tell me. Just to improve voltage gain, this is what is your feedback resistor. This is what is RE is the feedback resistor, which is what is going to have negative feedback. But what type of negative feedback? There are many types of negative feedback, but in control systems we always negative feedback. But in the circuits we have 4 types of feedbacks. Those feedbacks I will explain from feedback amplifiers. Okay, what is the name of the circuit? Applying input voltage at base with respect to ground, taking output voltage at collector with respect to ground for both input and output. This is base, this is collector, this is emitter, right? For both input and output, which is common. Emitter is not common because emitter is not at ground, because we have RE, right? Therefore remember, this is not common emitter, just common emitter but RE. Therefore the name of the circuit is CE with RE amplifier. CE with RE amplifier. This is what is having negative feedback. But anyway, I am going to explain this from feedback amplifiers also to see what type of feedback and all. But here, this is from circuit to improve the gain stability. We are incorporating negative feedback resistor. Then, but how it is negative feedback and all, I will not explain now. Let us solve all AC parameters. Then let's see what is voltage gain. Is it stable or not? Okay. Now let's calculate all AC parameters. Let us treat it as a problem. And this is what is the circuit, right? Now we need to calculate all AC parameters. voltage gain, current gain, input impedance and then output impedance. But finally we are interested, or I'm interested for only voltage gain. Okay, that part we will see. Therefore indirectly I'm covering the theory and I'm giving you the formula also, like AC parameters for your configuration. Remember, for this configuration, because this is not common base, it is not common collector, it is not common emitter. If one of the terminals of BJT is common, then whatever formula we derived, those are valid. But now this is not common emitter, CE with RE, the formulae whatever we derived till now, they are not valid, which we need to rederive or we need to recalculate for this configuration. Using simplified model we can go ahead, because you can treat like load will be less than or equal to 4K, then you can go ahead with simplified model. Then let me give you, because this is what is the formula with simplified model only, then let's compare for the voltage gain. Okay, just don't write anything, listen. Let me replace your transistor with simplified model, then let's have based on the definitions, let's have all AC parameters. If I replace this, and then basically I'm trying to do AC circuit, therefore what is AC circuit? I'm just trying to draw AC circuit. AC circuit for your CE with RE amplifier. Okay, maybe for your understanding, this is what is providing, this is what is your negative feedback resistor. Negative feedback, this is what is negative feedback component, this is what is providing negative feedback. Okay, now AC circuit, first of all transistor, therefore we know the transistor simplified model which we had seen, therefore this is HIE and this is what is our HFE into IB. Okay, and this is what is our, therefore this is nothing but your base and this is emitter, this is collector. This is what your transistor. Now what are all connected? Tell me, between base and ground your input is applied. Between base and ground input is applied. This is your VI. This is ground. Reference is always ground. Between emitter and ground RE is there. Between emitter and ground RE is there. This is RE. Between collector and for AC circuit VCC is connected to ground, right? Therefore VCC is connected to ground. Between collector and ground RC is connected to ground. Therefore for AC circuit between collector and ground RC is connected. This is your RC and this is your V0, right? Therefore this is what is your amplifier. Sorry. The black one is nothing but your BJT. Therefore this is what your amplifier now with feedback. RE is the feedback resistor, right? What else maybe that is internal, applying input voltage here, taking output voltage, and this is what your load. Therefore with respect to the load, this is nothing but your load current IL, and the current which is entering into, actually this is what your collector current, this is actual current. This is what your actual current means. This is base current, this is collector current. Now we need to represent emitter current. Therefore this is nothing but your emitter current IE, and this is what is your emitter terminal, right? This is IE. But for the load both are opposite. Therefore because with respect to load, the current which is entering into load is nothing but your load current. Therefore that is exactly opposite. IL is equal to minus IC. I just did AC circuit and then representing input voltage, input current, output voltage, load current, and load current is opposite to real current flow which is collector current. Okay. Now let's calculate all parameters. First one, don't write, listen. Again, let's follow the sequence. What is the first one? First one is nothing but current gain. Tell me what is current gain definition? The current which is what is entering into the load, IL, and the current which is what is entering into your amplifier, IB. Right? Therefore, now tell me What is IL? This is the definition. Remember, if you understand the definition, derivation is straightforward, which is what we did before, and then we were doing also, and we are doing now. What is IL? IL is nothing but minus IC. What is IB? Current entering into. Maybe I can represent that here only. Therefore, I can draw the vertical line. This is nothing but minus IC divided by IB. What is IC? In series, current is constant, right? That is nothing but what? HFE into IB. Minus HFE into IB divided by IB. IB will be cancelled. Then what is your current again? Minus HFE. This is what is your current again. Out of 4 AC parameters, 1 AC parameter is done for your CE with RE amplifier. Okay, this is extra configuration. Now let's see the other one, which is nothing but current gain, right? Maybe I can, yeah, I think I can start from here, right? Second one, input impedance. What is input impedance definition? The impedance seen from input port. What is impedance seen from input port? Is nothing but, this is what your amplifier, therefore the impedance seen from input port. This is what is your RI, right? Therefore what is that input impedance? Can you calculate directly? Therefore this is what your input impedance, right? Which is nothing but what? Internal to transistor, if you go transistor amplifier circuit, HIE plus RE, right? No. Tell me, when can you add two resistors? We can add two resistors when they are in series. How do you know they are in series? If same current flows, right? Let's check whether same current is flowing or not. What is the current which is flowing through HIE? The current which is flowing through HIE is nothing but what? IB. Therefore this is IB. And what is the current which is flowing through RE? Is it IB only? No, there is another current which is coming here. KCL, this current plus this current. Therefore, what is IE? IE is equal to IB plus HFE into IB. HFE into IB. Basically, that is nothing but 1 plus HFE into IB. This is what is the current which is what is flowing through the resistor RE. Therefore tell me, the current which is flowing through HIE and the current which is flowing through RE same? No, therefore they are not in series. Then how will you calculate? What is input impedance? Simple, from the definition we can calculate. Therefore what is the definition? Is nothing but input voltage and then input current. The amount of input voltage which is applied and the amount of current which is what is entering into your amplifier. That is basically your input current IB. Right? Now, we can apply KVL. What is input KVL? If you apply input KVL, what is your VI? If you apply input KVL, VI is nothing but the drop across this voltage resistor plus the drop across this resistor. Therefore, tell me what is VI? VI is equal to the drop across HIE, which is nothing but IB into HIE plus the drop across RE is nothing but what is the current? 1 plus HFE into IB into RE divided by IB. This is what is your current, right? Now, IB, everything will be cancelled. Then it is simply HIE plus 1 plus HFE into RE. This is what is your input impedance. Out of 4 AC parameters, 2 are over. Now, the third one, just wait. After completion of this, I will give you time to write down. Now, the third one, voltage gain. What is voltage gain? And that is what we are interested for, okay? But let's calculate all AC parameters. Now, what is voltage gain? Definition: output voltage by input voltage. V0 by Vi, right? Therefore, tell me what is V0? Can I write it IL into RC? IL into RC divided by what is VI? Every time we are writing the same thing, right? What is VI? Can I write it like, because we know effective input impedance RI into IB, or what is VI? RI into IB from input impedance. We were using this continuously. Therefore, IB into RI, that is VI. What is IL by IB? IL by IB, current gain. Therefore, this is nothing but, again we got the same formula basically. AI into RC divided by RI. Maybe instead of RC, if it is RL, maybe you'll get RL. Anything is fine. Therefore, this is what your voltage gain definition, right? Now, I think we can substitute. Then you will get voltage gain. Therefore, what is that? AV is equal to, if you substitute, what is AI? We got minus HFE. Therefore, minus HFE into what is RC? RC only divided by what is RI? HIE plus 1 plus HFE into RE. This is what is your voltage gain, which is the third formula. Okay. Now the last one, the fourth one. You may guess why. I just kept only little space. Means what does it mean? We don't need much space. Why? Let's see. What is the definition of R naught? Exclude the load. That is the definition, right? Exclude the load. The impedance seen from output port. The impedance seen from output port when input is 0. There is no Vs. But if Vs is 0 means Vi is 0, right? When Vi is 0, Ib is 0. When Ib is 0, HFE into IB is 0. When HFE into IB is 0, infinity means open circuit. Infinity plus something, infinity. Therefore, what is your output impedance? Your output impedance is straightforward, infinity. Because of what? Because of current source what you have here. Okay? Take all of those. Therefore, we got all 4 AC parameters which we are interested for any configuration, right? But ultimately I am looking for voltage gain that I need to compare. Then I need to see whether voltage gain stability is improved or not. Okay? Take it. I'll give you a couple of minutes to write down, but try to write faster. I think with this session, I can say BJT small signal AC analysis, that is over. Over? Okay. Now let's have the observations. Okay. We derived all AC parameters for the configuration CE with RE. But again, I'm highlighting a point. We should not use the formulae. We derived AI, RI, R0, okay, and AV, because those formulae are valid only for common emitter, common base, common collector. But this is not a common emitter. It is CE with RE. Because of that extra resistor RE, we should not use those formulae, right? Because the common terminal should be grounded. That is what we had seen and then we derived. But here the common terminal is not grounded, it is having some RE, that's why we derived once again. Okay. Once you understand the derivation, how many times you want we can derive. Okay. We can replace the BZ with the proper model, whether it is simplified model or exact model. Here we used the simplified model and then we continued, then we got all these 4 AC parameters. Even though we are able to solve all 4 AC parameters, maybe for the problems solving, I understand we need all these, but if you ask me to cover the concept what we are dealing now, which is nothing but gain stability, right? I am looking for only voltage gain, and I am going to speak now from voltage gain perspective, okay, to say whether voltage gain got stability or not. Okay, let me erase. I want these 2 circuits, let me keep as it is. Okay, and again I am going to use the box of AV. I can erase this part. Okay, before speaking about the gain stability, whether it is there or not, okay, that's fine. Maybe because you have written already. If you see the voltage gain, still it is depending on H parameters, right? Minus HFE into RC divided by HAE plus 1 plus HFE into RE. Still it is depending on H parameters. Before considering this configuration with feedback, I told a point. If you want to improve the stability of the system, it should be independent of H parameters. Then only I can say it is stable, because H parameters are changing with respect to temperature, time and replacement. Therefore, it is not stable. But even I told that if you want to improve the stability, we have to apply negative feedback. Then I told this is negative feedback resistor, and then we solved it. But still, your voltage gain is depending on H parameters. If your voltage gain is still depending on H parameters, how can you say stability got improved? Yes. Maybe you may have the doubt. If you don't have, now I created the doubt. Normally we will have, right? Still it is depending on H parameters. How can I say the gain is stable? Let me explain. Okay, just listen here. Don't bother about this. I'm going to little bit about from control systems. If you take open loop amplifier, instead of taking G of S, I'm taking A. Therefore, if you consider open loop amplifier, this is what is our gain A. Let us say your open loop amplifier, this is nothing but your open loop amplifier, right? Then your gain A is not stable. Your open loop amplifier gain is not stable. And from control systems, to improve the gain stability, we need to apply negative feedback. Maybe after applying negative feedback, let us say this is what is our gain A, and this is what is our H of S, but I am calling this as beta network, and it is not transistor beta. Remember, that is not transistor beta, that is beta network or passive network. That is what is the terminology people follow. And let us say this is what is something like this. Then now this is what is with feedback. Then if you say this is what is, now I can say this is nothing but your system with feedback. When I say this is the system with feedback, this is what is your closed loop amplifier. This is closed loop. I'm giving the connections like voltage amplifier. Okay, this is what your closed loop amplifier. Then tell me what is closed loop gain. Let me call closed loop gain as AF. Gain with feedback. Therefore, this is simply open loop gain. Now gain with feedback. If you consider G of S, H of S, that is G of S divided by 1 plus G of S and H of S. Instead of that, A divided by 1 plus A beta. Am I correct? Right? Tell me, your open loop gain is not stable. To improve the stability, we applied a negative feedback. Therefore, it is in closed loop. Then we got closed loop gain which is equal to A by 1 plus A beta. Then you say, how can you say this is stable? But we applied negative feedback, right? And this is what your transfer function which we dealt till now from control systems, and then we continued. Let me tell you, still your closed loop gain is depending on your open loop gain. Still your closed loop gain is depending on open loop gain. But we know that open loop gain is not stable. Means this is not stable. No. Let me apply a condition such that it will be independent of A. Then therefore what is that? To make the AF stable, if A beta, right? If A beta is very much greater than 1, can I neglect 1? Yes. Then A beta, A will be cancelled. Then what is your closed loop gain? Then your closed loop gain AF is equal to 1 by beta. Now this is what is stable. Now I can say this is what is stable because it is independent of open loop gain. Now it is independent of open loop gain, where open loop gain is not stable. Now it is depending on only beta network, where beta network is nothing but passive network which is stable. There is no variation. Maybe if I apply that here, you will get it. Okay. Now the same thing. Common emitter amplifier, what is your voltage gain? Minus HFE into RC divided by HIE. Right? Therefore, let me exactly write here. Therefore, if you take, I don't have space, but you can imagine. Therefore, this is what is open loop and then closed loop. But when you draw, you just try to represent below that only. Therefore, this is what it is. Now, if you take CE amplifier, which is nothing but your open loop amplifier, then tell me what your voltage gain we got. We got AV is equal to minus HFE into RC divided by HIE. And I told that this is not stable. It is exactly same as your open loop gain. Okay. Now coming back to CE with RE amplifier. Therefore, if you speak about CE with RE amplifier, remember this you need to write here. We should write these two in parallel. Therefore, you can compare. Okay. Therefore, CE with RE. If you take CE with RE amplifier, right? Then what your voltage gain we got? AVF is equal to minus HFE into RC divided by HIE plus 1 plus HFE into RE. This is what we got, right? Now I want to make it independent of H parameters. I want to make it independent of open loop gain. Then this is the condition. Similarly, if 1 plus HFE into RE is very much greater than HIE. If this is true, typically it is true, then can I neglect HIE? Yes. If this is very much bigger than this, I can neglect it. Then what is this? 1 plus HFE, 50, HFE is not a 50, 1 plus 50 is approximately 50. HFE, 1 plus HFE will be cancelled. Then what you get? Then your AVF is equal to approximately, it is simply minus RC divided by RE, which is ratio of resistors, always stable. Therefore, now this is stable. Your gain is stable, provided this condition is true. It is like provided if A beta very much greater than 1. Therefore, your voltage gain is stable. You may say it is depending on resistors. Your resistor is also a function of temperature, right? That's why it is defined with temperature coefficient alpha. Then how can I say this is stable? Remember, it is depending on ratio of resistors. When I say this is depending on ratio of resistors, either both will increase or both will decrease, but always try to maintain the ratio almost constant. Therefore, that is what is stable, and it is independent of H parameters. That is what we thought, and then we started, then applied negative feedback blindly. We got the advantage of having the stability. I hope this is clear, right? Now write down. Then I can say whenever you want stability, remember you can go ahead with a negative feedback configuration, which is nothing but CE with RE amplifier. But there is a disadvantage, the gain is very less. RC, let us say 4 kilo ohm, RE let us say 0.5K, then you will get gain 8. Instead of gain which is in the order of hundreds of, means it is in the order of 100, now it became less than 10. 100 versus less than 10. Therefore significant gain reduction. But remember, that is stable. That part, right, I will explain, but maybe you can write down. Okay, that part you can write down. Maybe observations I'll give you. But now I got it, we got it right. If you go for CE with RE amplifier, we got stable gain. That is what we want, we got it. Now let's see the observations part. Okay, write down. But try to, that's what I'm saying, even though it needs these many, but try to put CE with RE in parallel, just to compare, okay? I'll give you 2 more minutes, then after that I'll give you observations, then I'll stop this session. Done? I'm getting that, not done. Visualization, okay? Okay, now, maybe here only you can write, this is not stable, but high. Not stable, but high. That you can write. That is stable, but low. Therefore, what is the meaning of it? Just a point after writing it. The meaning of this is nothing but, let us say, this is CE amplifier voltage gain. This is CE with RE amplifier voltage gain. Okay. The CE amplifier voltage gain is very high, but it is not stable. It is fluctuating because of other parameters. Then apply negative feedback. When you apply negative feedback, the gain is reducing, but it is stable. Right? The gain got reduced, but it is stable. If you want more gain, if you are okay with the fluctuation in the gain, go ahead with gain. You want gain stability. I don't want gain, but I want gain stability. I want like 8, 6, 5, 4. I want gain in the order of 10. Go ahead with negative feedback. You understand the point? Therefore, Whenever you want stability, go ahead with negative feedback. Whenever you want gain, not stability, go ahead without negative feedback, or you can say common emitter amplifier. You understand? I'm speaking with respect to CE amplifier and CE with RE amplifier. But don't take as hard rule saying that I'll go ahead with CE with amplifier because my gain is stable. Stable but low. At the cost of something. If you want something, at the cost of something. If you want something, stability at the cost of gain reduction. Therefore, you think about it and then choose based on the application. Okay? That is what is very important. It is not always that this is true and this is best. There is nothing called best. That depends on the requirement. That depends on the application. Okay? Hope this is what is clear. Now, let me stop now. Then we can continue in the next session. I can say the topic BJT small signal AC analysis is over. Then we can continue maybe workbook problems from the next session. Then we will see the other things. Okay? Then after solving few problems, I can say we can go for DC analysis, BJT DC analysis. Once the BJT DC analysis is over, see how we are seeing different configurations or different AC circuits in the case of AC analysis. We'll see different DC circuits in the case of DC analysis. And remember, we will choose one of the better options from DC analysis, then choose one of the better options from AC analysis. We got that, CE amplifier. Then combine, then you'll get combination. That is what your final amplifier, which we are going to see. And for the final amplifier, we will see frequency response analysis, right, etc. Thank you.